So welcome to grade 11 physical sciences construction video. I'll be showing you how to do this the way I do it. There are many ways to do this, but let's just go with the way your teacher does it, and hopefully it helps you to understand. Now we're going to deal with three forces in equilibrium, which implies that their net resultant force is zero, which will imply that we have a closed triangle of forces. So let's look at the steps. Step 1, when dealing with these, draw a free body diagram and label all the angles. Work them out. You'll usually have to use alternate angles. Just work everything out as far as you can. It's really useful for these type of drawings. So number 2, we break up the vectors, draw them separately. If you can do this in your mind, it's okay, but it's nice to do them separately according to scale, and include the angles at both ends of every vector, at both ends. It's very important to do it at both ends, using alternate angles to do that. Next, we will form a triangle, and the best way I find to do this is to always start with a vertical line. Whether you know what it is or not, you just start with a vertical line. If you don't know what it is, we just draw a very long one, exaggerate its length, and then hopefully the other two vectors will end up cutting it somewhere, and then we know how long it is. Anyway, and then the next one, we'll draw the one we know, and if there's a third unknown, we'll do that one. So usually, at the very least, you'll know one of the vectors or their angles or something. But let's just go according to this route, known or unknown. So draw a vertical line, known or unknown. Like I said, there's other ways to do this, but this can work. Known or unknown. All right, so here is a question that I got out of a textbook, but right, there it is. So there's this ball hanging from two strings that are attached to a wall, and the ball has a weight W, and roll. So what do we know? We know they give us the angle of the tension in the rope to the wall there, and we have 60 degrees there. We can just draw this. It says your tension 2 is 80 newtons. We're working in newtons. Now, if they give you the mass of this thing, you have to convert it to newtons. Remember, Fg is mg. So if they give you the mass, you have g, so you can work out the force then. Now, determine W and T2 by construction. Sorry, I think it's T1. T1 by construction, because T2 is given to us. So the first step was draw a free body diagram. They're not asking for it here, but just do it. Free body diagrams are amazing in basically all physics. So let's take a look. Let's just do like a rough one here. We have T2 going in this direction. We have a W value. We don't know how big it is. We'll figure it out by construction. And then we have a T1 going this way. And just watch those directions, because T2 is going this way because the rope is pulling the object upward. It's not pushing it downwards. Ropes always pull, they don't push things. Okay. So what I like doing is drawing these little Cartesian planes, or I don't know, whatever you want to call them. Just at these 90-degree lines, dotted lines at the end of everything, so we can see what's happening really. It's really important here, because if you look at T1, taking a look there, it attaches to the wall at 80 degrees over here. So that will be 10 degrees over here, right? Because those are supplementary angles. Going alternate angles, we have this is then 80, and this will be 10. And looking at our tension 2 here, it's 60 degrees to the surface there, so write down 60, and 60 plus what gives you 90, so 30 over here. And using our alternate angles, we have 60 degrees here and 30 degrees there. Very important to do this. Simplifies the whole process. All right, now some of you might be able to just do it from here and just shift things about. But let me draw these vectors separately so we can have an idea of what's going on. Okay, so I drew the downward vector over here, but now I'm drawing the T2 vector. T2 came from here. There's our T2. T2 up here. I drew it there. I actually did measure the angle of 60 and drew it with a protractor. So that's T2. And T1 will look like this. Yeah, I'll go through this one slowly. So seeing where T2 is, so I'm going to say T1, it's over there, just highlighted it. We can just take it out and draw it separately. So it says there it's at 10 degrees from this point here. So let me just measure that quick and get the line out. Alright, there it is. Just drawing these two up. There we go, I joined it up. Let's move my W this way. And we draw a nice little Cartesian plane there. And we know from this diagram, a rough free body diagram, that this will be 80 degrees and this will be 10 using alternate angles. We have then 80 over here and 10 over here also. So it's basically a puzzle game from here. We actually know what T2 is. We'll do the scale now. They say it's 80 newtons. So we can draw it, everything according to scale, and then it'll work out. So this is basically what you should have going, and we can form a triangle. But let's figure out a scale quickly that's going to suit my tablet here. Try and think. 8 centimeters looks about. Okay, I'll do 1 centimeter as to 10 newtons. Alright, so there's my T2 vector. Which I drew over there. I just drew those solid lines so I can see, I measure it more accurately. Alright, so here's my T2 vector. What I did was I had a starting point here, draw my little Cartesian plane, make sure everything is nice and horizontal, and then I measured with my protractor 60 degrees, drew this line to exactly 8 centimeters because my scale is 1:10 and this is 80 newtons. So this is 8 centimeters, which is 80 newtons. So this length is exactly 8 centimeters. Alright, in T3, we don't know how long it is, but we do know the angles at which it operates. So there it is there. I might actually just use that. Did I measure that? I'm not sure. Let me just draw it here quickly. Okay, so I'm going to start a nice horizontal line. I'll rub it out now. And I'll measure at 10 degrees from the horizontal. So I'll do it quick. Alright, so there it is. I measured. Oh no, I'm split it back. Just make little dots and then. Okay, so I'll be 80 degrees up here and then 10 degrees down here. And we finish up this little Cartesian plane up here. We have 80 degrees up here, and then it's like very small, but that's 10 degrees down there. Alright, so this is my T3. So what do we do now? Oh man, I think I'll go horizontal. I had so much coffee, so my hand's like shaking a bit. It's quite tough to draw these things on this tablet. Hopefully I didn't zoom out and mess up my. Let me just double check. Yeah, so it looks right. So step 1 was it step 2 now? Actually, it was step 3. To form this triangle, we are going to draw the vertical line first. So this is just a way to explain how it all works together, but obviously you don't have to redraw these all the time in your test. But you can just start with a vertical line in your test. We don't know how long it is. I'm going to draw an exceptionally long one, and if need be, I'll just extend the tail. I'll just extend the tail upwards if I need a longer length. So we know that we don't know how long this line is, but we know it ends somewhere. So it's going to end somewhere. That will be our starting point for our next vector, which is going to be the one we know, right? The known, if there's another vector that's known. And that will be, if there isn't one, then just whatever, just use the angles but I don't think that will work. But anyway, use the one that's known, which will be T2, which we drew over here. So I'm going to move it so that you can see how it works. So we know that this is exactly correct, how it is drawn. So I'm just going to place it on this exact point here. And what did I just do? Yeah, looks about right. There it is there. So that is my second vector. And then my third vector, which is my T1, I don't know how long it is, but I do know the angles at which it operates. So I'm going to draw down in where we know the exact length of this T2 vector, which is exactly measured as 8 centimeters on this tablet. So I'm just going to go and connect it to where T2 ends and make a cut across like this. So it does seem like our weight vector is not long enough, so I'll just extend it. Let me just get that right quick. Right, I think I sort of fixed that. It took me like 5 minutes. And there's a nice little gap here. See that gap? I don't know. Anyway, so let me just. Okay, so we got a T1 here. Let me just label that T1. And this is our W, our weight vector. So T1 will be attached to, its tail will be attached to the head of the T2 vector, and it cuts over there. According to scale, let's hope, it cuts over here. So now we have our triangle that is according to scale, and we can actually figure everything out. You can measure this angle, you can just work it out with maths. So if we do, that's 70, 30, this should be 70 plus 30 is 100. We have to have 80 degrees here, right? If we work it out, let me just measure it quick to see if that's correct. Okay, so I got about 81, or 80,5. So that worked out quite nicely. So it looks like it's nicely done. Anyway, so all right. So what do they want? They want us to they want to know what is the magnitude of the W vector. Oh, by the way, so this actually can just be like a working outline, doesn't count. Now we can measure the W vector, just make sure this thing catches like that. Okay. Now I got 7,6 centimeters. So we said 1 centimeter is 10 newtons, so we just multiply by a factor of 10. So it'll be 76 newtons. All right. And for T1, we do the same. We measure and see. I got 4,1 centimeters, which is then 41 newtons. So this is very close to what I got doing it in pencil. So here we go. That answers the question they want, and that's pretty straightforward. I hope that helped. Start though. Let me know if you guys want me to do another one of these. Now, oh, by the way, before I carry on, this can actually be mirror imaged. Hold on. Right, so I couldn't actually get the can't rotate the thing. So anyway, like if your diagram looks something, I'm trying to mirror image this thing. It's a bit on. Sure. Let's just follow my rules and just start with the vertical, right? Okay, that's about right. If yours looks like this and it's mirror imaged, it will be wrong. But if you were to, it's wrong because our T2 vector cannot be, it has to be to the right. But I'll show you now what it can look like. I think I might have said something wrong there, just hold on. So we start with our vector going down, and if we were to start with the, I don't know why you would do this, but the T1 vector next, and then we end with the T2 vector, that will also be a correct way to draw it, because you have to have tail to head. You can't have two tails meeting in this diagram. Okay. Right, so let me know if that, well, don't let me know, but I hope that helped you, and hope it helps for your test you're going to write soon. All right. Have a good one.